Hello and welcome to the course of Computer Network Part 2. And today we are going to discuss about one of the random access protocol uh, with the name CSMA, which stands for Carrier Sense Multiple Access. Before this particular protocol CSMA, which we are going to discuss in this particular lecture, we have already studied two random access protocols before this lecture. The first one was pure Aloha, and the second one was slotted Aloha. The efficiency of pure Aloha is 18%, and the efficiency of slotted Aloha was increased, and it is 36%. Now today we'll see how CSMA works and how what is the efficiency of CSMA. So CSMA is nothing but it's a random access protocol used for multiple access links where a single link is shared by multiple nodes. And one of the important thing and most beautiful thing about this particular protocol is that unlike your pure Aloha and random slotted Aloha, this particular protocol CSMA, which stands for Carrier Sense Multiple Access, it listens before transmit. That which I mean to say is it sends your channel before transmitting the data. If your channel is busy, then it will delay its transmission, and once this particular protocol finds the channel ideal, then only it sends the data. As it says, carrier sends multiple access. It means that before sending the data, it senses the channel, and if it finds the channel ideal, then only it sends the data. So as it says, if channel sends ideal, transmit the entire frame. If channel sends busy, defer transmission. It's just a simple analogy. When n number of people talk to each other, then it's quite simple that don't interrupt others. Let them complete first, and then we'll start. So that is how it works. Let's see. uh, let's suppose we have got four nodes, and a single link is shared by these four nodes, and this is time axis, which is going downwards, uh, increasing time downwards. So let's see how it works. And still collision can occur because due to propagation delay, uh, two nodes may not hear each other's transmission. So how the other nodes present in this particular network will get to know about the transmission of this particular node. Let's take an example. This particular node starts its transmission at t is equals to 0, and the other nodes are present in this particular network as well, and this particular node senses the channel at t is equals to 0 and finds the channel ideal. But the other nodes will get to know about the transmission of this particular node when the first bit of this particular node will reach to their network interface cards. So at this particular point, this particular node will get to know about the transmission of this particular node, and this particular node will get to know about the transmission of this node at this particular time, because when the first bit of this particular node touches the network interface card of this particular node, then only it will get to know about the transmission of a frame from this particular node. So how the nodes are going to sense the channel? They just check the voltage level of the link, and it checks the signal strength which is coming from the link. So if that signal strength is more, that means there is some other node as well data present in that link. Um, in this particular example, when a single link is shared by four nodes, if this particular node start sending its frame at t is equals to 0, and this particular node starts sending its frame at t is equals to 1. So when this particular node sends the channel at t is equals to 0, it finds it idle and it starts its transmission. And when this particular node uh, this particular node wants to transfer its frame at t is equals to 1, and it sends this particular channel, it finds it ideal as well, because at this particular time the first bit of this particular node hasn't reached this point. So this particular node also finds the channel idle, and it will start sending the data, and at this moment the data collide with each other. So you can see a data collision occurs at this point, and you need to retransmit the data again. So propagation delay plays a vital role in this particular protocol, because propagation delay is nothing but it's a time required by a single bit of information to reach from one node to the other. It's simply distance by speed. If you want to calculate the propagation delay, it's distance by speed. So for the successful transmission of a particular frame through this particular protocol, you need to add one more thing in this particular protocol. That's name is collision detection. So we are going to study CSMA, which stands for Carrier Sense Multiple Access Collision Detection. In collision detection technique, uh, when when a node finds a particular channel idle, it starts sending its data, and it keeps on sensing the channel throughout the transmission of its frame. Then only it will find the collision, or it can detect the collision, uh, and then only it can abort the transmission and reduce the channel wastage. So detection is more important while transmitting your data, because if you find if you find the detection, that is one of the basic things. So this is the example of CSMA carrier sense multiple axis collision detection, where this link is shared by four nodes, and this particular node starts its transmission at t is equals to 0, and this particular node starts its transmission at t is equals to 1, and this particular node will get to know, because when it starts its transmission, and after starting its transmission, it's keep on sensing the channel while transmitting its frame. So during the transmission of its frame, it's kept on sensing the channel, and this particular node will get to know about the collision at this particular time. Sorry, at this particular node will get to know about the collision at this particular time, when the first bit of this particular node touches its network interface card at this point, and this particular node will get to know about the collision at this particular point when the first bit of this node touches the network interface card of this node at this particular time. So collision happened at this point, but they get to know at uh, these points of time. and once they detect the collision, they immediately abort the transmission and sends the jamming signal to the other nodes of uh, the network. So that's how it goes. The algorithm runs. A network interface card receives datagram from the network layer. As we all know that in TCP/IP protocol suite, uh, data link layer receives the data from its upper layer, which is network interface card. And once data is at the network interface card, your network interface card sends the channel, and if it finds the channel ideal, then it will start transmitting the frame. And if that NIC senses the channel busy, it waits until the channel is idle, and then it start transmitting its frame again. And one of the best part of this particular protocol collision detection is your uh, your NIC is keep on sensing the channel throughout the transmission of a particular frame. So if NIC transmits the entire frame without detecting another transmission, NIC is done with the frame and it will send the next frame. And if NIC detects another transmission while transmitting its frame, it immediately aborts the transmission and sends a jamming signal. So that is a beauty, and that is a beautiful thing about this particular protocol. So after aborting, after finds the channel um, busy or detect a collision, it immediately aborts its transmission and enters in binary exponential phase. It is also called back off phase, and it is one of the important thing about this CSMA CD protocol. And if your network interface card finds it, there's a rule for it. If your network interface card finds mth collision for a particular frame, then your network interface card chooses k at random from the range 0 to 2 to the power m minus 1, and it would be a random value of k between this range. And NIC waits till k into 512 bit times and returns to step 2 means if NIC sends the channel ideal, starts frame transmission. If NIC sends channel busy, waits until channel ideal, and then again start transmission. So this random wait time uh, is from the is also called a exponential backoff phase, or it is k into 512 bit times. And here's the efficiency of CSMA-CD, and this is the efficiency of CSMA-CD. T propagation is maximum propagation delay between two end nodes in a particular LAN, or that maximum delay is in between two end nodes. And T trans is time to transmit maximum size frame. So your efficiency goes to 1 if propagation delay or propagation time goes to 0. If there is 0 propagation time, then there will be no collision, because whenever a node has a frame to send, first of all it finds the channel. If that particular node finds the channel idle, then only it will start sending its frame. And if there's no propagation delay, then the other node will immediately get to know about the transmission, and they will abort, sorry, they will not transmit their frames, and they will defer their transmission. And once they find the channel idle, then only they'll try to send the data. So if your propagation delay goes to 0, your efficiency goes to 1, and your transmission delay goes to infinity, then your efficiency goes to 1. So better performance than Aloha, and it's simple, cheap, and decentralized. So that is how your CSMA CD works. I hope this particular topic is clear to you. And it's just a brief introduction again about this topic, that carrier sense multiple access collision detection is a random access protocol which is used for multiple accessing. When a single link is shared by n number of nodes, then you can use CSMA CD in wired or wireless local area networks. And before sending the data, this particular algorithm uh, try to sense the channel, and if it finds the channel idle, then only it will start transmitting its data, and it will keep on transmitting and it will keep on sensing the channel while transmitting its data for detecting the collision. And if it finds the or it detects the collision, then it immediately aborts its transmission and sends the jamming signal and enters in an exponential backup phase, which is very important, which is k into 512 bit times. So it's just a brief introduction of our complete lecture. I hope it is clear to you. Thank you very much. Have a good day.